Welcome back. Today we're going into section 6.6 on phase shift. So we're going to sort of dust off some of the skills that you hopefully remember from your college algebra days, but just in case. So if we have y equals, say, f of the quantity x plus c, so now there's something inside with the x. Y is then the graph of f of x shifted one of two ways. If c is positive, so in other words it's truly x plus something, remember inside works backwards, we are shifting left. Absolute value of c units. C is less than 0, so in other words it's f of the quantity x minus something. Shift right by absolute value of c units. And remember, sine and cosine have a period of 2 pi, so in other words one complete cycle happens on the basic sine or cosine function from 0 to 2 pi. Basic meaning only one thing's happening. We're just doing a sine or just doing a cosine. We haven't introduced these guys. These guys will change where that happens. So we'll start with one that just has a phase shift. So y equals sine of x minus pi over 4. So what this is going to do is we're going to start with just y1 equals sine of x, and we'll draw our 5 basic points and one more cycle. So sine of 0 is 0, sine of pi over 2, 90 degrees, remember your unit circle is 1, sine of pi, we're back to 0, sine of 3 pi over 2, we're back at negative 1, and at 2 pi, now we're back at 0, and then we have one more of those cycles. So 5 pi over 2, now we're at positive 1 again, so that's pi over 2 plus 2 pi. 6 pi over 2, or 3 pi. Now we're back at 0, and so on. So there's 2 full cycles of the basic sine x. We'll do these guys in red, and really we only have one thing happening on these guys. So this is inside. We're looking at less than 0, so we're shifting right, absolute value of c units, right pi over 4 units. So what happened at 0, 0? This guy is now at 0 pi over 4. This guy that was at pi over 2, 1, pi over 2 plus pi over 4. So that's 2 pi over 4 plus 1 pi over 4 is at 3 pi over 4. We have an output of 1. Pi plus pi over 4, 5 pi over 4, we're back to 0. Three pi over 2, or 6 pi over 4, plus 1 pi over 4 is 7 pi over 4. And our output is back at negative 1, and 2 pi or 8 pi over 4 plus 1 pi over 4 is at 9 pi over 4. And our output is 0. Alright, so there, those in red are now the sort of 5 key points. So notice, at least within the limits of my ability to sketch in freehand, we kept the exact same shape and everybody just moved to the right pi over 4 units. So then I'll just draw in one more cycle, but I only have to put labels on my 5 key points. Alright, so the next one we'll do a little bit more work to it. But same ideas. We'll just go over some of the other things that we've been able to do to these functions in previous sections. We'll do y is 5 cosine of 2x plus 3 pi. So before I do anything else, I want to factor here first. I want it to be in x minus c form, so I want to factor that part first. So I want to turn this into y is 5 times the cosine of, we'll factor a 2, and we have x plus 3 pi over 2. Okay, so a few things happening to this. This is changing the period. So after we get our basic cosine function going, we'll deal with that. Making this guy a little bit taller because I'm suspecting my amplitude is also changing. Alright, so we'll start with just y1 as basic cosine of x. So cosine of 0 is 1. Cosine of pi over 2 is 0. We head up to pi. Now we're back to our cosine being a negative 1. Then 3 pi over 2. Cosine is back to a 0. And 4 pi over 2, or just plain 2 pi. 2 laps around, now our output is back at the 1. So here is one cycle of the basic cosine function, and again we'll draw a second one in there as well. And we'll have to use a little imagination and pretend that I can draw these a reasonable distance apart. So there's our 4 pi, 7 pi over 2, 3 pi, and 5 pi over 2. And we'll round these out with arrows, of course, since that pattern continues forever in both directions. Alright, so next up, we'll take care of the period change. So remember, inside, this is now being compressed by a factor of 2. If it helps you to use the formula, that never really helped me that much to do the formula way, but omega over the 2 pi over the omega, we now have a period of pi. So what happens at 0 stays at 0, but now what happened at pi over 2 is happening at pi over 4. What happened at pi is now happening at pi over 2. What happened at 3 pi over 2 is now happening at 3 pi over 4. What happened at 2 pi is now happening at 1 pi. So now here's one complete cycle. And of course then that will repeat. I'll draw in just one more. Okay, so we smashed it in a bit. And scooched a little off the page there if you want to write down that. Omega equals 2 for those of you that like the formula way. Period is now t equals 2 pi over 2, which is pi. Okay. The old country song, one piece at a time. So now we'll stretch these guys out. So, just like before, a times f of x is the old graph of f of x with all the y values multiplied by a. So 1 times 5 is 5. 0 times anything is 0. Negative 1 times 5 is negative 5. 1 times 5 is 5. 0 times anything is 0. So now here is one complete cycle. We are stretched quite a bit vertically, and we are compressed horizontally. This guy stays nailed down for the second cycle. This guy's down here at negative 5. This guy's nailed down at 0, and this guy's back up at positive 5. So we did all of the compressing and stretching vertically and horizontally. Then we just finish it off with any of the shifting. So the plus 3/2, plus is going to take us left, so everybody in blue there is moving to the left by 3/2. And that's our final one. So left 3 pi over 2. So what happened at 3 pi over 2, now that's happening at 0. What's happening at pi over 2, 3 pi over 2 minus 3 pi over 2 is negative 2 pi over 2, or negative pi. And so on. So all of the blue points are moving to the left by 3 pi over 2. So this guy was happening at pi, so 2 pi over 2 minus 3 pi over 2 is negative 1 pi over 2. And so we're crossing at pi over 4. And here we go. Alright, So I do want to trace what happened to my 5 key points. So this guy at last step in blue was at 0, 5, and we went left 3 pi over 2. So we have negative 3 pi over 2 is at the 5. This next point was at pi over 4, and we went left 3 pi over 2, or 6 pi over 4. So negative 5 pi over 4 is at 0. Our next point here was at the pi over 2. And again, we went left 3 pi over 2. Negative 2 pi over 2 is negative pi. Our next point was at 3 pi over 4. And we went left 3 pi over 2, or 6 pi over 4, to get us to negative 3 pi over 4. And that returned us to the 0. And finally, what happened at the pi, or 4 pi over 4, went left 3 pi over 2. Oops. True but not helpful. 2 pi over 2 minus 3 pi over 2 is negative pi over 2. So at negative pi over 2, we had an output back at positive 5, and for some reason I wrote a negative 1 there instead of a negative 5. So there's our 5 key points. What happened to the original 5 points once we were done doing all this stuff to them. All right. Now, one thing that you might notice on that one, in fact, I should be able to squeeze it on this page. On an original cosine function, we have x on the interval 0 to 2 pi. So on this one, the 2x plus 3 pi would have been on the interval 0 to 2 pi. If I get the x by itself, that would show us these boundaries that we have here. So negative 3 pi less than or equal to 2x less than or equal to 2 pi minus 3 pi. And then we just cut everybody in half. So negative 3 pi over 2 is less than or equal to x less than or equal to 2 pi minus 3 pi is negative pi, so negative pi over 2. And there's our boundaries. So that does fit with what we already knew about the compressing and stretching. Just another way to sort of write it out as to where the 5 finals are going to be bounded by. Alright, so the last one, we'll just do a couple kinds of shifting, but otherwise similar ideas. We'll do y is negative 2 sine of, let's just do x plus pi over 4 plus 3. So we'll start this one, boil down to its basic function. Y1 is just going to be sine x. We're only shifting left by pi over 4, so I'm not going to have to go too terribly far to the left. So let's see, yeah. We'll use this and we'll be able to fit it in that way. And we don't have to stretch too much either, the amplitude of just 2. Alright, so sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is back to negative 1, and sine of 2 pi, we're back to 0. And then just one more of those. So sine of 5 pi over 2, we're back to 1. Sine of 6 pi over 2 or 3 pi, we're back to 0. Sine of 7 pi over 2, we're back to a negative 1. And sine of 4 pi, now we're back at 0. So there's two quick cycles of the basic sine function. This one, no horizontal stretching or compressing to worry about, so we'll just take care of that negative 2 next. So take all your old y values, multiply them by a negative 2. 0 times anything is 0, 1 times negative 2 is negative 2, 0 times anything is 0, negative 1 times negative 2, positive 2, and so on. So a vertical stretch, otherwise nothing super big on the change here. And since we don't have any horizontal stretching or compressing to worry about, I can just take care of the shifting last. So each of the points in red, the plus pi over 4 is moving us left pi over 4, the plus 3 is moving us up 3. So left pi over 4 and up 1, 2, 3. So what used to be at 0, 0, now that's at negative pi over 4, positive 3. Left pi over 4, up 1, 2, 3. So now this used to be at pi over 2. We moved it left pi over 4, so now we're at pi over 4. And our output, instead of being a negative 2, is now a positive 1. This guy was at pi, so 3 pi over 4 when we move them left, and then up 1, 2, 3. Uh, 3 pi over 2, 6 pi over 4, move left 1 pi over 4 is 5 pi over 4, and up 1, 2, 3. So 5 pi over 4 for our input value, and our output, we're at 1, 2, 3, 4, 5. 2 pi, move it left pi over 4, so 8 pi over 4, minus 1 pi over 4, 7 pi over 4, and move it up 1, 2, 3 units. And we're at positive 3. So there's our 5 key points, and then we'll just draw one more cycle. So next up it would be down here. Then back to center. And then up top. So there's sort of a rough sketch, free-handed in. This would be easier if we were meeting in person and I could give you a graph, but here we are. Alright, so some problems to try out. This was section 6.6. 3 to 17 odd should be sufficient practice. For those of you doing the My Math Lab thing, I'll try to find some rough equivalents in My Math Lab as well. If you have any questions, please feel free to get in touch with me. Otherwise, I'll see you next time, and stay safe out there.